Hello, today we are going to talk about International Advanced Level Physics, Unit 1 Mechanics and Materials, 1.3 Mechanics, 1.3.14 Principle of Conservation of Linear Momentum. The principle of conservation of linear momentum. Momentum is always conserved in any interaction where no external forces act, which means the momentum before an event, example, a collision, is equal to the momentum after. This fact can be used to find the velocity of objects after collisions. For example, a car with a mass of 500 kg and a velocity of 4 meters per second collide with a stationary truck with a mass of 1500 kg. The two vehicles join together and move on b of velocity v. Find the value of v. Before we see there is a vehicle 500 kg with 4 meters per second and 1500 kg truck with zero velocity. And after both vehicles join together, the total mass is 2000 kg. The velocity is v. First, find the momentum before the collision. Total momentum before is 500 into 4 plus 1500 into 0, which is 2000 kg meters per second. Total momentum before is equal total momentum after. Therefore, 2000 is equal 2000 into v. So v is equal 1 meters per second. Newton's second law states F is equal ma. Therefore, F is equal delta m into v divided by delta t, as A is equal delta v divided by delta t. From this, you can see that force is the rate of change of momentum. Using Newton's third law, you can see that the principle of conservation of linear momentum can also be expressed by saying that the sum of the change in momentum of the objects is zero. Newton's third law states for each force experienced by an object, the object exerts an equal and opposite force. So for two objects in a collision, label 1 and 2, the force exerted by 1 on 2 is equal and opposite to the force exerted by 2 on 2 1. Here, these are the objects 1 and 2. This is F1, this is F2. This can be written as F1 is equal to negative F2. So apply Newton's second law and delta V divided by delta T as above. M1 into V1 divided by T is equal to M negative M2 into V2 divided by delta T. M1 into V1 divided by delta T is equal negative M2 into V2 divided by delta T. Finally, you can multiply both sides by change in time, as this will be equal in a collision between the two objects. So M1 into V1 is equal negative M2 into V2. So P1 is equal negative P2. So P1 plus P2 is equal 0.